So what we're starting off today with is chapter 2.11. 2.11. We're breaking up chapter 2.1 into two parts, and we'll finish it on Monday. But what we're starting with this chapter is reasoning and proofs. And we use a lot of reasoning and proofs to show that the statements are true, that the theorem's true, that they work. And this is a way that we can prove them. Now, throughout the rest of geometry, once we've proven something's true or gone through the proof or seen the theorem, we can actually use it. We don't have to show it every single time we want to use it, which is nice because it's going to make a lot of our work a little bit easier. Now, the first thing we're looking at is conditional statements. A conditional statement is a logical statement that has two parts, a hypothesis and a conclusion. When a conditional statement is written in if-then form, the if part contains the hypothesis and the then part contains the conclusion. Really, a conditional statement is what? It is a statement that contains a hypothesis and a conclusion. So a statement that contains a hypothesis and conclusion and is written in if-then form. So we can say if P then Q, or P implies Q. So it contains a statement that contains a hypothesis and
Trey Duncan,
conclusion.
come to the office. Trey Duncan, come to the office.
It's really a conditional statement is a logical statement that contains, or a statement that contains a hypothesis and conclusion. If then, if P then Q. An if then statement just really contains the word if, hypothesis, then conclusion. If this is true, then this must be true also. If today is Friday, then tomorrow is Saturday. If this, then that. And that's really what we'll be looking at first, and really rewriting statements or sentences in if-then form. And looking at the hypothesis and the conclusion. So we're going to use red and blue. I can use red and blue, but it's going to be a little bit harder for you all to do that. So we can underline and circle. So when we look at this here, to identify the hypothesis and conclusion, and then rewrite it in an if-then form. So what's our hypothesis? So our statement is all birds have feathers. So the hypothesis, I would say, would be all birds. And our conclusion would be have feathers. So we could underline and circle because all birds and have feathers. All birds have feathers. So we're talking about our hypothesis as if it's a bird and has feathers. Now, when we write it in if-then form, there are some statements we would have to change because we're not going to say if all birds. So if we're talking about something, we're going to say what? If what? It is a bird. Because we're talking about it kind of setting it up. Because like I said earlier, if today is Friday, then tomorrow is Saturday. Because we could also kind of in a more statement or just a sentence-wise, Saturday is always, or Friday is always before Saturday. Well, we can't say if Friday is always then Saturday, because we can't just take it as it's written. Sometimes we have to change it a little bit, because if it is a bird, then what? Has feathers. If it is a bird, then it has feathers. And the reason we like these conditional statements is because now I can actually test it. Because we could start off with saying that it is a bird is true, then we see does it have feathers. And anytime we have these statements, if we're proving true or false, and we'll get into that eventually, but we only need one case. If we can prove it wrong in one case, then it's not true. Let's look at the next one. You are in Texas if you are in Houston. What is our hypothesis? You're in Houston, and our conclusion is you're in Texas. In this one here, they flipped it a little bit, but what was the kind of big sign that the hypothesis was? Yeah, kind of gave it away. Well, kind of helped us. If you are in Houston, then you are in Texas. Now this one here is just like the first one, really only works one way. Because if we flipped it, if you are in Texas, then you are in Houston. Does that work? Let's try it a different way. Let's say instead of Houston, let's say Concord, and instead of Texas, let's say Oklahoma. Because if you were in Concord, then you were in Oklahoma. Yes? If you were in Oklahoma, then you are in Concord. Well, no, because I can go, 15 minutes south and be in Kansas, Oklahoma? Am I still in Oklahoma? Yeah. So this one here and that one, the other one that I just said, are both examples because it does work this way. But just because I'm in Texas doesn't mean I'm always in Houston. But this one does work this way. Questions on this here? All 30-degree angles are acute angles. What's our hypothesis? They're all 30-degree angles, or we can really 30-degree angles, because as we saw with the first one, the all part really didn't matter. We threw it out. Yes, when we wrote the if then. Then what? Are acute angles. Yeah. And I'm looking at this here and might as well just throw the R out because really our overall conclusion is the acute angles. If you circle R, I'm not going to mark it wrong. So let's write it in if then. If what? Yeah, so probably an angle is 30 degrees. I reworded that mainly because the other way just seems a little funny, just sounds funny. If a 30-degree angle, then, well, if an angle is 30 degrees. Because I'm phrasing it in this way to classify any angle. If an angle is 30 degrees, if it satisfies this condition, then what? Thank you.
Thank you, sir. Do you have a pencil?
Yep. Right in there. So if an angle is 30 degrees, so we're classifying if any angle is 30 degrees, then what? And it is an acute angle. We could have, yeah, exactly like y'all were saying, then it's acute. That works just fine. Because it's just, how do we want to phrase it? Questions on this here? Let's look at this one here. Sure. So we want to underline the hypothesis and circle the conclusion. 2x plus 7 equals 1 because x is equal to negative 3. What's our hypothesis? What's our conclusion? If what? Then? That's it. This one's a little bit more straightforward because we just have an equation. If this is true, then this is true. Now the other way around would be true, but it's kind of, it does work, but it's a little funky. Go in the other direction. You're welcome. Huh? Yeah, like the last one. Let's look at this one. So it'll be a little similar. X is greater than 5 if x is greater than 3. And we said the conclusion is? I like the way that works out. But will that always be true? If x is greater than 3, then x is greater than 5, yes? I just find that a weird statement. Yep, that's exactly how they have it. But what if x is equal to 4? Is 4 greater than 3? Then 4 is greater than 5. Well, no. But how we'd set this up is still if x is greater than 3, then x is greater than 5. And that's how we would do it, just the way they have this set up. The better way to do it would be having it flip, to say that if x is greater than 5, then x is greater than 3. That will always be true. Because if a number is greater than 5, it has to be greater than 3. Questions on this here? Let's do one more and then we'll move on, because I feel like y'all are getting the hang of this for the most part. Questions on this? Good? Okay. All members of the soccer team have practice today. So our hypothesis is what? All members of the soccer team do what? Have practice today. Mm-hmm. Now this one here, we'll have to change the wording a bit. Because what are we saying? What is it essentially saying? All members of the soccer team have practice today. So if what? Mm-hmm. So who's having practice? Soccer team, yes? So if what? So talking about the soccer team. So who's on? So the soccer team is practicing. So if they are almost, if they are what? Are on the soccer team. Because we're really wanting to clarify who we're talking about. If this statement's true. Because then they have practice today. So that if statement is really classifying what are we talking about. Because we could say all members of the soccer team, well, they could be on the football team or the other sports, So we want to state in such a way that we're talking about this individual group. If they are on the soccer team, then they have practice today. If they're on the soccer team, then they have practice today. All right. I feel like the book's probably keeping this simpler than this. If a person's a member of the soccer team, then he or she has practice today. And that's it. Questions on this here? Negation. This here I have found every year to be y'all's favorite one to do. The negation of a statement is the opposite of the original statement. A negation is the opposite of the original statement. And that's really all I would write down, is the opposite of the original statement. We use this little squiggle line to signify negation, and we'll say it as not. So not P. So the little squiggle P is saying not P. We're negating it. We're saying the opposite of it. And I'll talk about this again later, but this here, negations are one of the most useful tools in proving something is true. Because as I said earlier, for us to be able to say that a statement is false, we only need how many examples? One. But if we're dealing with something that's true pretty much all the time, it's kind of hard to prove it, because even if I prove that 1 million examples work, what about the million and first? Because the first million could work, but the million and first one couldn't. Well, okay, we proved that the million and first one does. Well, what about the million second and the million third and the million fourth? Because it could be one after it does work. But the negation of it, the opposite of it, if I can show that that is false in one case, what does that mean? That the original statement must be true, because the opposite of true is. So if I prove that the negation of the original statement, the false statement, is true, or prove that the opposite of it is false, the opposite of false is, I can prove the original statement is true. So sometimes in mathematics, when they struggle to prove a statement is true, they find the negation of it, the opposite of it, and if I can prove it's false, it means the original statement must be true. Okay. That's it. The ball is not red. Yep. The cat is black. Because we're just saying the opposite of it. So it says the ball is red. Well, we're going to say the ball is not red. It says the cat is not black. So the negation of it, the opposite of it, is the cat is black. So we're not trying to say that the ball is blue or green or any other color. We're just saying it's not red. Because the original statement said it is red, so the negation of it is not. That's it. The original statement says the cat is not black. Well, the opposite of it, the negation of it, would just say that the cat is black. Because really, we're just taking the statement from true to false or false to true. We're not changing it any other way. The car is white. The car is not white. It is not snowing. Its negation is, it is. I think we got this, yes? The shirt is green. Its negation is the shirt is not green. The last one, these shoes are not red. The shoes are red would be the negation. Questions on this here? All right, related conditions. Consider the statement below. If P, then Q. So that would be our normal if-then, our conditional statement. Its converse would be if Q, then P. Well, what did I do? I switched the hypothesis and the conclusion. To write the converse of a conditional statement, exchange the hypothesis and conclusion. We're going to exchange the hypothesis and the conclusion. So converse is switching the hypothesis and the conclusion. Yes, I'll pass out the test once everybody's finished. There are still some who haven't. So I don't like to pass it out until everybody's completely done. We good with this here? Yes. Because we have two more. We have the inverse and the contrapositive. Now, before, you can write all this down if you want. This is also all in your book. Because these here, I just take them straight from the book. So let's look at the inverse. To write the inverse of a conditional statement, negate the hypothesis and conclusion. So really, we have our conditional statement. The converse is flipped. The inverse is the negation of the original statement. And the contrapositive is what? We negate. So our normal statement is P implies Q. And we'll call this the conditional. The converse is Q implies P. The inverse is not P implies not Q. And the contrapositive is not Q implies not P. So we almost have our if then, flip, negate, flip again. If P implies Q, converse if Q implies P. Inverse, if not P implies not Q. And the contrapositive is if not Q implies not P. The conditional statement in the contrapositive and the converse and the inverse are going to be connected. If the conditional statement is true, normally its contrapositive will be true. If the converse is true, the inverse will be true. A conditional statement and its contrapositive are either both true or both false. Similarly, the converse and inverse of a conditional statement are either both true or both false. They work together. And it'll make more sense when we actually see an example of this and see how this works. Okay? This part of the assignment is not difficult, it's just tedious. Let P be, you are a guitar player. And let Q be, you are a musician. Write each of these statements and decide whether they are true or false. P implies Q. Well, what is P? So we can say for A, if you are a guitar player, then what? Then you are a S-I-C musician. So we'll do true and false here in a little bit. Let's just write the main statements down. So we good with the first statement so far? So the converse, what did we do? Flip P and Q, yes? If you are a musician, then you're a guitar player. The inverse, if, so not P implies not Q, yes? Well, our P statement was if you play, or you are a guitar player, yes? So the negation of it is if you're, what? Not a guitar player, then you're not a y'all agreeing that this is not that difficult to write these out? It's just tedious because they're just having to write the same statement essentially 4 times over in a different way. Now the last one is if, or not Q implies not P. It says if you're not what? A musician, then you're not a what? Okay. See if I can get you to disappear. Let's go with the yellow. Okay. Any questions on how we wrote these 4 statements? Are we good with this here? So let's go back and look at true or false. If you're a guitar player, then you're a musician. Are guitar players musicians? So this here would be true. You can write it out to the side. I'm going to write it on top. Because in the end, it doesn't matter. Because this is true, yes? Let's look at the next one. If you are a musician, then you are a guitar player. Are there other? Because you can play the drums, you can play the sax. I mean, there's so many different musical tools, but just because you're a musician doesn't necessarily mean that you have to be a guitar player. False. All we need is one case. If you're not a guitar player, then you're not a musician. False. Because just like we said earlier, you can play the bass. That's not a guitar. Or if you play the saxophone. Just because you say to play the saxophone, well, you're not a guitar player, but you're still a musician. Last one. If you're not a musician, then you're not a guitar player. True. Well, what happened? The two, like we said, the converse and inverse. have the same false, and the conditional and the contrapositive have the same. And those will always work together that way. Questions on this here? Do we feel good with this? Do we need to see another example of writing this all the way out? No? That's it. Because really those last four, the conditional, the converse, the inverse, and the contrapositive, they give you the setup for it, P and Q. Fill in P and Q and do the nots to it, and then decide whether it's true or false. And with those there, especially come on the test, I would look back at them on your paper, and if you can justify, because I'll mark them the way that I think about it and look at it, and if you can give me a good justification for the way that you thought about it, I'll give you the points back. Because a lot of them can be a little tricky depending on how they're worded. For the test especially, I will make sure that they're worded in such a way that it's easy to tell true or false, or I'll just remove the true or false from it. Because almost, if you are not at school, then it's the weekend, or if it's the weekend, then you're not at school, kind of stuff.